All right, this starts Unit 8 today. We are going to be talking about classifying triangles for the first lesson. Our whole first lesson is actually all about triangles here. So we're going to start off with talking about different triangles here that we have. So we're going to talk about first by angles. So we have different triangles that go by their angles. We have a acute triangle, which is going to have 3 acute angles, and you can see all those. There's an example down here. An obtuse triangle is going to have 1 obtuse angle. It can't have any more than that because of a rule that we're going to learn about triangles momentarily. And a right triangle is going to have 1 right angle. And again, we'll kind of talk about angles in just a second here. An equilateral triangle, when we're now talking about sides, an equilateral is going to have 3 congruent sides. And we're going to see these little tick marks that are going to be on the sides of the triangles. That's going to signal to us that they're going to be equal length, which means they're congruent. In an isosceles triangle, you have at least 2 congruent sides. So those 2 sides would be the same, and then that one would be a different one as well. So isosceles would have at least 2. In a scalene triangle, there are no congruent sides, so we could mark these all with different numbers of tick marks, and that'll show us that all the sides are different. Every triangle that we have has a double name. So we name the triangle by its angles and also by its sides. On page number 3, talking about some special properties of triangles, the first property is one that you might already know. The sum of the interior angles of a triangle is going to be 180 degrees. I'll try and show this to you here. This doesn't always work out super well, but I'm going to go ahead and outline the angles of this triangle here. And it's a little bit complicated, but we'll make it work. And here's angle 3. That wasn't a very good one, but we'll try and make it happen here. So if you were to actually take all those angles and twist them around here, the idea is that you can actually see that when you put those 3 angles all together, you do actually have a straight line. And this one, again, like I said, didn't work out completely perfectly, but it kind of gives you a general idea of what we're talking about here. So the concept is that forming them all together gives you that straight line, which is right across the bottom there. So you could do it if you had a piece of paper and you cut out a triangle and then you ripped off all the edges, all the corner pieces. You could actually lay them together and then you would actually have a straight line, which is kind of cool. So for these, it's kind of like what we did with angle problems in the last unit. We're going to go ahead on this first example. I have 2 angles are given, n is blank. So I'm going to go ahead and add 50 plus 95. And that's going to give me 145. So to get n, I have 180, which is the total, and I'm going to take away that 145, leaving me with 35 degrees for n. When we look at one like this one, this is a little bit more complicated, so we are going to actually have to write an equation here. So we're going to add up the 3 angles. So we have 3x, we have 7x plus 30, and we have 2x, and they're going to add up to be 180 then. Combining your terms here, you're going to have 12x plus 30 is equal to 180. Taking away that 30, you're going to be left with 12x is equal to 150. Oh my goodness. I'm jumping ahead here. And dividing through then by 12, I'm going to get that x is equal to 12.5 degrees. So what we could do is we could actually plug that back in, and if we did 12.5 times 3, this would be 37.5. This one would be 25 degrees, and 7x, 7 times 12.5 plus the 30, this one would be 117.5 degrees. So we could figure out all the missing angles here. In our next relationship, we have relationship number 2 is a relationship between the sides and the angles. So the shortest side is opposite the smallest angle, and the longest side is opposite the largest angle here. So when I'm looking at these, 1 appears to be the largest angle here. So 1 is larger than all the other ones, and 1 is opposite side C. So side C and angle 1 are actually going to be our biggest here. If we look between 2 and 3, 3 is actually our smallest angle, and that goes across to side A. So angle 3 is smaller than angle 2, which is smaller than angle 1. So that tells me in order, side A is going to be smaller than side B, which is going to be the smaller than side C. So biggest angle, biggest side, smallest angle, smallest side, and the medium angle is going to go with the medium side. So in example 3, what's the largest angle of the triangle and which one's the smallest? Looking at these 3 different numbers, if I'm looking for the largest angle, I need to find the largest side. and then I need to go across the triangle to get to my angle. So the largest is going to be angle E, and the smallest is going to be over here. This is the smallest number, and going across, that's going to take me to angle F. In example number 4, a triangle has the angle measures shown. Write the sides in order from shortest to longest. So shortest would go with the smallest angle, so that's going to be R, which is less than the 52, which is going to be side T, which is going to be less than the biggest one, which is side S. So R is less than T, which is also less than S. In example 5, refer to the triangle. Write the side lengths of the triangle in order from least to greatest. We have 2 of the angle measurements, but we're missing that one. So I'm going to go ahead and add 37 plus 101 together, and that's going to give me 138. So to find my missing angle, I'm going to do 180 minus 138, and that's going to give me 42 degrees for up here. I needed to know what that was so I could figure out, is that the smallest, is that the middle one? And it is in fact the middle. So we want to go from greatest to least here. So starting with the biggest angle, that's going to take me across to side B. The medium angle is going to go over here to side A, which is going to be less than the smallest, which is over here at side C. Notice that the angles are written with uppercase letters and the side lengths are written with lowercase letters. That is going to be super important for us. For our last angle measurement pieces, we're going to talk about the triangle inequality theorem. And I'm going to make an extra video to go along with this to kind of display this to you a little bit more visually. So I'll have that coming for you as well. But for right now, what the triangle inequality says is that the length of any side of a triangle is less than the sum of the other 2 side lengths. The other side of that is that it also has to be bigger than what the difference of those 2 is. So if we know sides A and C, we're able to kind of figure out what a range could be for side B, and we're able to figure out if this can make a triangle. So it tells us right here. What does this do for us? If we know 2 sides of a triangle, we can find a range for the length of the third side by finding the sum and the difference of the given sides. If we know 3 lengths, we can actually use 2 of them and determine if the lengths do in fact make a triangle. So in example number 6, Marina uses chalk to draw a triangle on the sidewalk. 2 sides have the lengths of 15 inches and 22 inches. What are the shortest and longest possible lengths of the third side, assuming it's a whole number? So we're going to take our 15 and our 22, and we're going to add them first, which will give us 37. We're going to also subtract them. We want to do bigger number minus the smaller number. So 22 minus 15 is going to be 7. So what this tells us is that our third side has to be between 7 and 37. However, it cannot actually be these 2 numbers. So if we're looking at whole lengths, our shortest possible length is going to be 8 because it's in between 7 and 37. Think about on a number line, if this is your 7 spot and this is 37, you're in between here. So our whole number that we first approach is 8. And our longest possible side has to be smaller than 37, so one smaller is going to take us down to 36. These are both going to be inches here. Taking a look at example number 7, is it possible for side lengths 5, 8, and 15 to form a triangle? You can pick any 2 numbers, but I'm just going to pick the first 2. And your job is to go ahead and add them together, which will give you 13, and subtract them, which is going to give us 3. So our third side has to be somewhere between 3 and 13. Take a look at your third number. Is 15 in between 3 and 13? If you're on a number line, 3 here, 13's up here, 15 is actually up here. So your range is somewhere in between here. 15 is outside of your range, so this is not a triangle, and your explanation is because 15 is not between 5 and 8. For example number 8, which of the following can be the measure of the third side of the triangle if the other 2 sides are 2 and 5? So you're going to add these 2 together. You're going to subtract these 2, or 5 minus 2, which is going to give us 3. Our third side has to be somewhere between 3 and 7. It's not allowed to be 7. It's not allowed to be 3. Is 6 in between 3 and 7, or is 12 in between 3 and 7? 6 yards is the one that's in between, so 6 yards would allow this to actually be a triangle. That's it then for your lessons on triangles. So this is lesson 8.1.